Hello. In this video, we're going to see how a teacher can use manipulatives to show the students how to balance chemical equations. The manipulative that we're going to use is our snap cubes, where each color will represent an atom of a different element. The colors are different, then the element is different, and when they're together, they snap together, this will represent a molecule. Okay, for our first example, we're going to look at how we can balance the chemical equation where we have hydrogen and oxygen, and it's going to produce water. Now the hydrogen I'm going to represent with green snap cubes, but I have two together because that's what the subscript means, that there's two atoms of hydrogen together to give me that molecule. So I'm going to show here that green is hydrogen. It's my little key, so I can keep track of what's what. And then for oxygen, I'm going to represent that with orange. So I'll say my orange is going to represent oxygen. And then for my product, I have two hydrogen and an oxygen. So it's going to look like this. I'm not worried about the electrons, the configuration. I'm just looking at the number of atoms. So when I see this, what I see is that I have two hydrogen on the left and I have two hydrogen on the right. So that balances. There's the same number on both. But I also see that I have two oxygen on the left, but only one on the right. So it tells me that I need to have another oxygen. But I can't just put an oxygen by itself like this. It has to be with the two hydrogen. So when I do that, it's going to look like this. I'm not going to put them together because I want to see now I have two molecules of water. But since I've done that, my oxygen balances, but my hydrogen doesn't. So because I have four hydrogen atoms and I only have two on the left, so if I put two more, now I see that I have four hydrogen atoms on the left, four hydrogen atoms on the right. I have two oxygen atoms and I have two oxygen atoms. So my equation is balanced. So when I go to show that or to write that, then I have two hydrogen atoms, one oxygen, and then I have two molecules of water. You don't need to write the one, but I like to write the one so I can see that there's actually one there. And then you can have your students just copy it. Using, like if they were to draw it, then they'll have a record of it for next time. Okay, let's look at another example. Here I have potassium oxide and water, and it's going to yield potassium hydroxide. So let's say for potassium, the atoms of potassium, I want to represent that with blue. So that's going to be my potassium. I'm going to use orange for oxygen, like I did in the previous example. And I'm going to use green for hydrogen. Okay, so when I go to build this, for my potassium oxide, I have two atoms of potassium and one atom of oxygen together. Now I have, for the next molecule, I have two atoms of hydrogen and one atom of oxygen together to make a molecule. And that's going to yield potassium hydroxide, which is one atom of potassium, one atom of oxygen, and one atom of hydrogen. So we see that it's not balanced because I have two potassium on the left and I only have one on the right. So then I know In order to get my potassium to balance, I need another molecule of potassium hydroxide. So when I put my whole molecule, I can't break it apart and just get one. I have to do the whole molecule. So now what I see is I have 2 of the potassium, and I have 2 atoms of potassium. I have 2 atoms of oxygen, 2 atoms of oxygen, and I have 2 atoms of hydrogen and 2 atoms of hydrogen. So my equation is balanced. So then I can go and write in my coefficients. I have 1 potassium oxide molecule. I have 1 molecule of water, and I have 2 molecules of potassium hydroxide. Okay, in this next example, potassium nitrate is going to break down into potassium nitrite and oxygen. So let's go ahead and build each one. I'm going to use the blue to represent the atoms of potassium. I'm going to use black to represent the atoms of nitrogen, and I'm going to use orange to represent oxygen. So on the left-hand side, I'm just going to have 1 atom of potassium, 1 atom of nitrogen, and 3 atoms of oxygen, and they're all connected. So here's my molecule. On the right-hand side, I'm going to get as a product, I'm going to get 1 atom of potassium, 1 atom of nitrogen, and 2 atoms of oxygen stuck together, plus some oxygen molecules. So I see here my nitrogen balances, my potassium balances, but my oxygen doesn't. But when I look at it, I'm kind of looking for some patterns, because I don't want to use the manipulatives forever, but I want to notice some patterns. And what I notice is that I have 3, and over here I have 4. I have an even number. Notice in the equation that I have 2 oxygen here and 2 oxygen over here. So in order to get an even number of oxygens, for them to be in groups of 2, I'm going to have an even number over here of molecules, because I have 3, so I'm going to need to have at least another one so that I will have an even number of oxygen. So now I see that I have 6 oxygen. So then here, instead of putting the 2 more oxygen over here to make 6, what I'll notice is, oh, I added in another potassium and another nitrogen, so I need to put those first. So here I'm going to add another molecule of potassium nitrite. So now I have the right number of potassium molecules, which is 2. I have 2 atoms of nitrogen, and I have, over here I have a total of 6. I have 2, 4, 6. So therefore, now my equation is balanced. But notice what I was thinking over here when I was looking at that I had groups of 3 atoms. So I know I need to have 2. At least I need to have an even number of groups so that I can get my numbers here for my oxygen to work out. So when I go to write the coefficients, those are the numbers in the front, just like they are in algebra. I have 2 molecules of potassium nitrate, 2 molecules of potassium nitrite, and 1 molecule of oxygen. Okay, let's look at another example. So in this example, we have a molecule of nitrogen, a molecule of hydrogen, and it's going to yield some molecules of ammonia. And let's see how many. So the nitrogen has 2 atoms together, and I'm going to use black for nitrogen, I'm going to use green for hydrogen, and I'm going to for my ammonia, I have 1 nitrogen and 3 hydrogen. So I can see that my equation isn't balanced because I don't have the same number on the left of atoms on the left as I have on the right. So when I'm going to look at the hydrogen, because I see that I have 2, and over here I have 3. So because 3 is an odd number, I know that I need to have an even number because my hydrogen is traveling in pairs. So they're in groups of 2. So I have to have at least another another molecule of ammonia so that I will have an even number of hydrogens. So now I see that I have 6 hydrogen, and so I only have 2 over here, so I need 2 more. And then I also see that my nitrogen, I have 2 on the right and I have 2 on the left. Some of you may have seen, well, let's do the nitrogen first, because I have 2, so you would know that you needed 2 molecules on the right hand side, which is fine because there's not just one way to do it. Okay? But now it matches, the number of atoms on the left match the number of atoms of each element on the right. So for my coefficients, I have 1 nitrogen molecule, I have 3 hydrogen molecules, and I have 2 ammonia molecules. So the coefficients don't need to match. What needs to match are the number of atoms. Let's look at another one. Okay, in this example, phosphorus and oxygen are going to react and give us phosphorus pentoxide. I'm going to use yellow to represent phosphorus. So I'm going to place 4 atoms of phosphorus together to make a molecule, and 2 atoms of oxygen together, and it's going to yield the phosphorus pentoxide is 2 atoms of phosphorus and 5 atoms of oxygen. And we can clearly see that it's not balanced. But when I look at this and I see my 5 oxygens, what I notice is that's an odd number. And oxygen by itself always is in pairs. So I have to have an even number. And so I'm thinking an even number, okay, 5, I need another 1, and when I put another 1, that now I have 10 oxygen. You might be able to start making an association between 10 oxygen and the fact that I have 5 oxygens in that molecule and 2 atoms per molecule by itself. I'm looking for patterns. Okay, so now I see that I have 10 oxygen, and I have 2 here. I need 4, 6, 8, move them up, and 10. Okay, because I'm noticing that 2 times 5 give me 10. Kind of association there. And then I see that I have 2, in the 2 molecules of phosphorus pentoxide, that gives me 4 atoms of phosphorus. I have 4 atoms over here. So my equation is balanced. So then I have 1 molecule of phosphorus, and then I have 5 molecules of oxygen and 2 molecules here. And I can quickly see that 5 times 2 gave me my 10, 2 times 5, there's something going on there. Okay, let's see if we can continue the pattern. Okay, let's look at this example where I have phosphorus and bromine, and it yields phosphorus tribromide. For my phosphorus, I have 4 atoms of phosphorus together. That gives me 1 molecule of phosphorus. 2 bromine atoms together to give me a molecule. And then for the phosphorus tribromide, I have 1 phosphorus and 3 bromide. So I know that because this is even and there's an odd number here, because there's 3 here, I know I need to have another one so that my oxygen will match. But I also notice that, so I can get my oxygen to match, but that's not the problem. I have 4 phosphorus here and only 2 here, so I need to have 2 more to address my phosphorus. So now I have 4 phosphorus and I have 4 phosphorus atoms on the right hand side. So we took care of the phosphorus, and now I need to look at the bromide. And so I have 3, 6, 9, 12. These are in pairs, so I need to have 6 pair. Because I'm noticing this one I could figure out without actually even counting, because I have 12 and they're in groups of 2, so I know I need 6 groups. So that gives me my coefficients, which is 1, 6, and here I can count, and there's 4. And then you can have the students just copy it, draw the picture so that they'll have notes that they can look at later. So let's look at this example where I have a molecule of sulfur, I have oxygen, and I'm going to get sulfur trioxide. So what I notice here is for my sulfur, I have 8 sulfur atoms together. So since I have 8 on the left, I'm going to need to have 8 on the right. But I also notice when I go to build this that I'm going to have, this is SO3. So I'm going to have a sulfur and I'm going to have 3 oxygen together. And since I have 8 of these, I'm going to need to have 8 sulfur over here. So when I have 8 here, that gives me 8 times the O3. That's going to give me 24 oxygen. I don't want to build it. But I've almost figured it out anyways. Because if I have 1 sulfur molecule, and that gives me, I need to have 8 on this side, because I have 8 right there, and I'm going to have, I need to have 8 right here, and now I have 8 groups of the O3, so I have 3 oxygen in each one of these molecules. I have 8 of them, which gives me 24, and so that will give me, or mean that I will need to have 12 of the O2s. Because I had 24 total over here, so 12 times 2 gives me the 24. And I can do that without actually building it, because I can picture it, but I don't want to build, I don't want to use 24 oxygen molecules. So I can see it, I can visualize it, and I don't need to work it out. Look at this last example here, where I have hydrosulfuric acid and chlorine, and it's going to yield sulfur and hydrochloric acid. So when I'm looking at all of these things to see where to get started, what I notice is that, again, for the sulfur, there's 8 atoms of sulfur together in 1 molecule. So if I have 1 of these, that's going to give me 8 atoms of sulfur. So over here, I need to have 8 atoms over here. So my sulfur takes care of itself. So when I do that, what I notice is that there's 8 There's 8 molecules, but each molecule has 2 atoms of hydrogen. So that's 2 times the 8, which gives me 16 hydrogen, which is why I didn't want to build it. So that's going to give me 16 hydrochloric acids molecules. So when I have 16 hydrochloric acids, so I have 16 hydrogen, I also have 16 chlorine atoms. So since over here, as on the left-hand side, they're traveling in groups of 2, in order to get 16, I need to have 8. And my equation is balanced. So just a quick check to see how many hydrogen I have. I have 2 times 8, which is 16. Here I have 16. The sulfur, I have 8 times 1, the subscript of 1. So that's going to give me 8. And over here I have a total of 8 atoms. And the chlorine, I have 16 of 8. And each one has 2 atoms in it. So that gives me 16. And over here I also have 16. So we work with the ones that have the largest numbers first. It's easier. Or if we have ones that have like odd and even, you're going to go to like the least common multiple to see how you can get them to end up with the same number. And that's how they can balance the equations. But once they're able to visualize it and understand what's happening, they don't need to use the manipulative. Thank you.